Okay, so getting into this video, we're going to take a look at abstract classes and abstract methods. So this video should be fairly brief since we just need to make a small adjustment to our shape class in order to make it abstract. I think overall it won't take a lot of explanation to fully understand what's going on here. I do also want to spend a little bit of time discussing about the benefit of doing this as well though. So we need to go ahead and find a way to modify our shape class so that we can introduce the getArea method. So we want to make sure that it at least exists somewhere within the code or the body of our shape class. But we don't necessarily want to try to introduce an implementation for it, like say giving it some kind of functionality, because of the fact that when we're dealing with just a generic shape, we don't necessarily know what formula we should use to get the area. So if you look at things like say our polygon with getting half of the apothem squared, our circle doing pi r squared, or doing our getArea for our rectangle, where we're doing the length times the apothem times 2, where the apothem is just supposed to be half the height or half the width. For each one of these, rectangle, circle, and polygon, we have some general, kind of specific understanding of what the area for that particular object is supposed to be, but with shape we don't necessarily know. And so what I want to do is basically just add a definition, or at least kind of the start of a definition for getArea, but I don't want to have to give it a body with any functionality. And the way that I can do that is with what is known as an abstract method. And so to make this an abstract method inside of this shape class, I also have to make sure that this class is abstract as well. So to do this, we just need to add the abstract keyword. So we're going to say public abstract class shape. And so now that we've got that, now we can add abstract methods to it. So to make an abstract method, we do pretty much the same thing. We just have to specify this abstract keyword. So we're going to say public abstract. We then want to go ahead and specify the expected return type for our getArea. So if we double check on each one of these, we can see that the return type was double. So we still want to keep that here. And we also want to go ahead and keep that name so that that's consistent between the shape class and all three of our other classes. So we'll say getArea. We'll have our pair of parentheses. If we had any parameters that we would need to specify, we'd go ahead and put those in as well. But then the only other thing we need after this, we're not going to put a body for this method. Instead, this is the entire line, and we put a semicolon at the end. So this is going to be one of the few instances where you see the header of essentially anything, whether that's a class header, a method header, or maybe one of these, say one of these headers, these clauses that we use for if statements. This is going to be one of the few instances where you actually see a semicolon at the end like this. Okay, and so now that we've got our abstract method, now whenever we go into something like say the polygon class, this getArea right here, this is no longer just its own standalone getArea. This is actually a getArea that is overriding the abstract getArea that we had here. So we just introduce a kind of definition, so just the couple of keywords that we need in the method signature, and then we actually go about implementing it by giving it some functionality inside of its subclass or child class. So I'm going to go ahead and add the overriding keyword here just to make sure that we can keep track of that. Okay, so we know that this getArea is overriding shape. I'll go ahead and do the same thing for circle right here. So I'll add that override keyword. And even though I didn't do it before, I'll go ahead and include it now just to make sure that we are being concise with everything. I'll go ahead and include the override keyword inside of our rectangle class as well. Okay, so now that we've got all that, now if I come back over here, I can now actually uncomment this line. And so now, because both shape and polygon have a getArea method in them, even though shapes doesn't do anything, now I can still override it, and now this will adhere to essentially the same dynamic binding principles as when I used getArea with poly1. So now if I compile this and try to run it, I won't get any errors. So if we come over here, we can go ahead and compile this, and now we run into a different error that I need to address. So because of the fact that I made shape abstract, when I have this line up here where I try to make an object of the shape class, well, if I try to make an object of the shape class the expectation would be that I want to later go ahead and use some of the methods from that class, but because of the way that I've set this up, I have a particular method that doesn't do anything. It just has no functionality assigned to it. So in order to avoid any kind of complications or issues that we might run into at runtime, there's a particular catch with abstract classes in Java, which is that we can no longer construct objects of an abstract class. So now we have to rely on polymorphism if we want to be able to make a reference variable from the shape class. So if you want something of type shape like this, say shape1, then the only way that we can actually use that is by assigning to it an object of one of its subclasses that actually does implement those abstract methods. So this line will now give us an error, so we need to go ahead and remove it. And then once we've removed that line from there, we can come back over to our command line, or from your project, and go ahead and just rerun this. We'll go ahead and compile it again. And now we can compile it without any errors. And then we can also go ahead and run it. And now we can see this line right here, where we're getting the area of the polygon shape is 40.5. So now we can actually access the getArea method from our polygon right here, because of the fact that it also existed in shape and we were just overwriting it in polygon. Okay. So now we're doing that. Now both lines 22 and 26 are following essentially the same process with dynamic binding. In addition to all of this, the one other thing that I want to talk about on the design side of things, since we've already seen a little bit about UML class diagrams using just our regular classes like what we have right here, we've also talked a little bit about having this inheritance relationship and showing that arrow notation. The other thing I want to talk about is abstract classes and abstract methods in our UML class diagrams. So if we come over here, I've got this abstract class in UML for our shape. So in this particular case, I'm showing a shape constructor which did nothing. We've got our getArea method, which is abstract. I also included a toString method for the class diagram, just in case you want to include that as well. But the two things to take note of are that the name of the class, as well as the getArea method, which is abstract, both of these things are now italicized to indicate that that these two things are abstract. So this indicates that the shape class itself is abstract, and this indicates that the getArea method is abstract. Okay. So at this point, this is going to cover everything that I wanted to say about abstract classes and abstract methods. Essentially kept this example fairly brief by just introducing it with the shape class to show making this abstract and adding an abstract getArea method. This is also going to complete all of the code related to this particular example using the circle, polygon, rectangle shape, and rectangle demo. Going into the next video, I want to take a look at interfaces. So this is going to kind of build on this idea of abstract classes. We're going to go one step further with that by looking at interfaces, and we'll take a look at a totally different example that introduces this concept of interfaces.